All right, welcome back. Today we're going to be talking about section 11.5 from your textbook, all about algebra of functions, different operations that we can do on functions. We can add them, we can subtract them, we can also multiply and divide functions, and then we can also talk about taking the composition of two functions. So let's start with the algebra of functions, this adding, subtracting, multiplying, dividing. Now, you'll recall from a previous section that we already did a little bit of this. We did it when we were talking about profit. Remember, profit was the difference of two functions. It was the difference of the revenue and the cost function. If we take revenue minus cost, we get profit. Well, we can do that with other operations too. And so there's some new terminology that I'm introducing right here. If you see f plus g of x, again, this is not f plus g times x. This is function notation. It's the sum function. F plus g of x is equal to f of x plus g of x. And then f minus g of x is equal to f of x minus g of x. And we could do this with a couple of examples. So remember from up above, if we see f plus g of x, this means f of x minus g of x, which in this case is going to be x squared, excuse me, this is not minus, it's plus. We're doing plus. F plus g of x is f of x plus g of x. So this is x squared minus 8x plus 35, and we are adding that to g of x, which is 2x squared minus 4x minus 7. Can we go any further past this, or do we just write it out and are we done? What do you think? Well, hopefully you're saying to yourself there's some like terms here. For example, we have x squared and 2x squared. We know that could combine to make 3x squared. And likewise, we have negative 8x and negative 4x. That can combine to make negative 12x. And then lastly, we have 35 minus 7 gives us a positive 28. So f plus g of x is equal to 3x squared minus 12x plus 28. And then we could subtract this notation, which I tried to write earlier, is f of x minus g of x, which is almost the exact same thing. It's x squared minus 8x plus 35, but instead of a plus here, we are going to be subtracting away 2x squared minus 4x minus 7. Now what do you think we're going to do next? What are we going to do with this minus? If you said distribute it, you're correct. So this is going to turn this from a positive 2x squared into a negative 2x squared. This negative 4x is going to become a positive 4x. And then this negative 7 will also become positive. So we have x squared, dropping the parentheses here, x squared minus 8x plus 35. And again, if we combine like terms, we now have 1 minus 2 is negative 1 x squared. Negative 8x plus 4 is negative 4x. And then plus 35 plus 7 is a plus 42. So f minus g of x is negative x squared minus 4x plus 42. What do you think about the last example, f plus g of 6? Well, we could just take and plug it in to this function right here that we already calculated. We already found out what f plus g of x is. Now we want to use that function to calculate it with an input 6. And remember, when we plug things in, we put parentheses around it, so this will be 3 times x squared, so 3 times 6 squared minus 12 times x, or 12 times 6, plus 28. It's 3 times 36 minus 12 times 6 plus 28. 3 times 36 is 108. 12 times 6 is 72 plus 28. Hopefully this is making sense so far. Then if we take 108 minus 72 plus 28, we get a total of 64. So f plus g of 6 is 64. Okay. Not anything too terribly difficult there. We can also multiply and divide functions, but as you might guess, if we divide, we cannot divide by what? We cannot divide by 0, because that's undefined. And so when you see these next two definitions, when we have f over g of x, that's f of x divided by g of x, but there's the stipulation here that g of x can't be 0. That's why that's written in there. And so go back here to, we got another couple of examples here. If I take f times g of x, this notation means f of x times g of x, which is going to be x plus 5. X plus 5 is f of x, and then x minus 2 is g of x. So it'll be x plus 5 times x minus 2, which again we should probably simplify. So this is x squared minus 2x plus 5x minus 10. Combining like terms, we get x squared plus 3x minus 10. So f times g of x is equal to x squared plus 3x minus 10. And likewise, we can divide here. So remember, f over g of x means f of x divided by g of x, which gives us x squared minus 3x minus 28 over x squared minus x minus 42. And this is a rational function. Do you remember how we simplify rational functions if they are able to simplify? Remember what we do? The top and bottom. Hopefully you're thinking to yourself that we should factor top and the bottom. So on the top we should have x minus 7 and x plus 4. And the bottom we should have x minus 7 and x plus 6. Can we do any simplifying there? Well, you should answer, yeah, the x minus 7's cancel. And what we're left with is x plus 4 over x plus 6. That's f of x over f over g of x. Okay, now a question that might be interesting to think about as well is, what is the domain? Are there any restrictions on this function? And the restrictions are, remember, go back to the previous page, the restrictions are right here. The restriction is that the denominator can't be 0, because then we get an undefined function. So if I come back over here, my denominator is g. It's x squared minus x minus 42. That cannot equal 0. It's my restriction. Well, if it can't equal 0, what values of x here would make it not equal to 0? Well, that would be true if we had x minus 7 and x plus 6. That would make it equal to 0, which would mean that x minus 7 can't be equal to 0 and x plus 6 can't be equal to 0, which means x can't equal 7 and x can't equal negative 6. So the domain is all real numbers except x equals negative 6 and x equals 7. So there are restrictions on these sometimes. There's my restrictions. Now we can take a look at an application problem involving adding and subtracting functions. If we take a look at this example, it says the number of U.S. undergraduate students can be approximated by this function here, where x represents the number of years after 2000. And then the number of U.S. graduate students can be approximated by this g of x function, where again x represents the number of years after 2000. So part A says here to add the two functions together. Well, if I do that, I'm going to take the 195,760x plus 13,554, 400. I'm going to add that to the g of x. When I add that, if I add the x parts together, 195,760 plus 41,780, I get 237,540 x, and then the 13,554, 400 plus the 2,224,700 gives us 15,779, 100. So this is our new function. Now what does that mean? What does that mean? If f is the number of undergraduate students and g is the number of graduate students, what does this mean? Well, it represents the total number of not only undergraduate but also graduate students in the U.S. X years after 2000. So what if the years after 2000 is 20? Then that's the year 20 years after 2000 would be the year 2020, and I could calculate it. f plus g of 20 would come out to 237,540,000 times 20 plus 15,779,100. Do that calculation real quick here. When I do that calculation, I get that the total number in the year 2020 is going to be 20,529,900. I almost said students, but I should say graduate and undergraduate students in 2020. Approximately, it's not exact. This is a approximation. Alright, so we are now going to take a look at another type of operation that we do on functions. It's called the composition of two functions. And what happens in a composition of two functions is first our input value goes into one function, say g of x, and then after we goes through that function, we plug it into another function, f of x, and it gives us an output. And the notation that we use is this, what I'm going to highlight here. It looks like, almost looks like it says fog, but that little circle there is not an O. It's what we use for composition. I can call this the composition operator, meaning that's it tells us to do the operation of composition, and it means, we see this, it means that basically the function x first goes into g and then that goes into f. We start in the very inside, so it's like the function g of x is inside of f of x, and the way we say it is we say f of g of x. If I was to say the symbols that you see there, I would say f of g of x. Okay, so let's take a look at an example and see how this composition of functions work. We take a look at example A. We're going to find f of g of x given the functions f of x and g of x. And the first thing that we want to remember is that this new notation can be defined or rewritten like this. So when we're doing part A, what this really means to find is to find f with g of x as the input. So what does that mean? We look here. G of x is the input. What is g of x? Well, we know what g of x is. It's given in the problem. Gx is this 3x plus 14. So I could go ahead and rewrite this. What we're trying to find is not f of g of x, but more specifically f of 3x plus 14. Well, this is something we've done before. We've done this many times. We've taken inputs other than just values or numbers and we've plugged them into functions. And what we do is we take our function f. Function f is right here, which has the form something squared minus 2 times something, or 2 times the input, minus 8. Now what's the input? What goes into each of these two open set of parentheses? Well, it's the input. It's the 3x plus 14 is g of x. So I can go ahead and plug in there 3x plus 14, and then also 3x plus 14 here. And then from here it's just algebra, it's just simplifying. We know that this means 3x plus 14 times 3x plus 14. We gotta write it twice. That's what the first part means. And then on the second part we have to distribute, so that's a minus 6x. Remember that negative sign goes with the 2 when we distribute to both places, so it's also a minus 28. And then don't forget to include the 8 on the end. Now we can multiply or FOIL out this first part, which gives us 9x squared plus 42x plus 42x plus 196. And then we have the minus 6x on the end, and also minus 28 minus 8 is minus 36. And then finally, if we combine all like terms, we end up with 9x squared. We have a 42x, a 42x, and a minus 6x, which gives us plus 78x. And then we have a 196 minus 36, which is a positive 160. That's how you would do part A. Now part B is similar, it's just backwards. This notation, if we rewrite it, means that we take g and we plug f of x into it. And what is the f of x that we're plugging in? What's the input that goes in right here? Well, we can replace it with what f of x is. F of x is this highlighted blue part. It's the x squared minus 2x minus 8. And just like in the last problem, that means that we're going to take g of x, which is 3 times something plus 14, and we're going to plug in our input, our x squared minus 2x minus 8. We plug in f of x. And then, of course, it's algebra. We just simplify. 3x squared minus 6x minus 24 plus 14, which is 3x squared minus 6x minus 10. Alright, so if we do this last example, we've already done all the heavy lifting for part C. We did it in part A. We found the general form. Right here, let's highlight it. We found the general form highlighted here in yellow. That is f of g of x. That's what the expression we get for any x is the input into f of g. But now we have a specific x. We have when x equals 3. That's the input. So we can just take 3 and plug it into this new expression, this 9x squared plus 78x plus 160. And so that would look like 9 times 3 squared instead of the x squared plus 78 times the 3 plus 160. Of course, 3 squared is 9. 9 times 9 is 81. 78 times 3 is 234. And then plus the 160. We add all those together, we get 475. Okay, now since we're looking at functions, the other thing we need to talk about is, are there any restrictions on the domain? The example we're going to look at here is, what if f of x looks like 3x plus 4, and then we have over 2x minus 1, and then g of x is 4x plus 7, and we want to find what f of g of x is. And remembering that that notation means to take the function g and plug it into the function f. It means that our function f, which looks like 3 times x plus 4 over 2 times x minus 1, instead of plugging a number in there, we're going to plug in our input, which is g, and of course g is what we have highlighted here. G is the 4x plus 7. And so when I simplify, I get 3 times 4x is 12x. 3 times 7 is 21. Plus 4, and then on the bottom we get 8x plus 14 minus 1. Combining like terms, we get 12x plus 25 over 8x plus 13. Again, just like the last time we had a fraction problem, this denominator cannot equal 0. Remember doing that when we were talking about dividing two functions? The denominator can't equal 0. Well, here the denominator can't equal 0. Well, what does that mean? That means that 8x cannot equal negative 13. I just subtracted 13 to the other side. I subtracted 13 away, and then if we divide by 8, we get that x cannot equal negative 13 over 8. So my domain is all real numbers except x equals negative 13 over 8. That does it for section 11.5. Make sure that you do your self-check. We'll see you in class. Thank you.